Welcome back, everybody, to FOP Day 13, I believe. Um, we're gonna pick off from where we left off yesterday. Before we cut, I assigned you guys the battle game, Dungeons and Dragon object-oriented programming assignments. Right. This is not in your curriculum, right? We are ahead of schedule, so we're just getting some more practice with object-oriented programming, with something that is a little bit more fun. Just for a show of hands, who here is familiar with Dungeons and Dragons? Not as in like I've heard of it, but I've played it or I know somewhat of the rules.
I played a couple games of it.
All right, everyone point and laugh at Keegan because he plays Dungeons and Dragons. But the rest of you
I
guys, just
man
kidding.
enough to admit it.
No, good stuff. No, I always wanted to play. I just couldn't get into it. Like I don't. I thought it'd be weird for me trying to play a part, but
It's
I've always been interested in it.
it's the company that comes with it. If you were with your boys drinking beer, it'd be a little different. But
Now, yeah, I can see how that is. I tried getting into it, and then I went to Barnes and Noble and I tried to purchase like the D&D books, and they were like $40 a book. And like there was different books. There was like a Dungeon Master book, there was like a character book, like a monster book. I was like, I can't afford this right now. So I was like, I'm not doing this. And then I started doing more research on it, and there's like whole like table sets, and you can make figurines, character sheets. I just feel a little overwhelmed. So I kind of needed somebody to kind of bring me in and show me the ropes. It was difficult for me to try to pick it up on my own, so I just never did. But it was something I've always been interested in. But we're going to try to replicate a little bit of it. It's not too crazy. I had to do my own little research with it of how it really works. So if you haven't played D&D, who here has played Baldur's Gate 3?
I made it through the tutorial.
I was playing it
Really?
before this, dude.
Okay, so you have an idea, right? The biggest thing that I want to take away from the Baldur's Gate 3 or D&D that you really should just know is how the dice rolls work, right? For everything that you do, there is you have to roll a dice and that'll
I
dictate
have
if
owned
you
dice
can.
before.
Well, that's Justin.
I have owned dice before though, so I'm familiar.
Okay, yeah. So no, you want to be able to use dice. Uh, so if you ever play a game like Baldur's Gate, any action that you do typically involves you like rolling the dice or rolling for it, and depending on your roll, and also your attributes will dictate whether your roll is successful or not, and so on and so forth. So we're going to have to really take that into account here. I didn't specify it right, but I'll show you how that's going to work here. It involved a little research on my own. Really, the research was just asking ChatGPT how does the dice work for Dungeons and Dragons, and it just explained it to me, right? So um, that's all it really took. But without further ado, let's go ahead and get into it. So I'm going to create three different files, which I already had created because I was working on this earlier. One's going to be for the dice. The other file is going to be for my characters. And then the battlegame.py will be my actual game class. Uh, we'll start with the character first and then move on to the dice afterwards, since the character is the first one. So I'm going to go ahead and copy this piece of code here and bring it over so I can read it. And then using this, I'm going to create a template for my character. Now, I could create two individual classes for my character class and my enemy class. But what I'm going to do is I'm going to create one parent class of what a character should be. And then what I'm going to do is use inheritance to create different versions of this character to make individual other players. And we'll see why that is very beneficial, right? So for those of you who are working on this, if you haven't started, you can code along with me, or you can kind of use this to reference your code. But I'm going to create a character class. And I'm going to give it my init method. And as you see here, it should have something like name. It should have a health, attack power, and defense. Let me zoom in a little bit. Go. And these are pretty self-explanatory, right? All right. So my base characters, every character that I create should have name, should be able to have a health stat as well as attack power or defense, right? If this was like a normal non-playable character, doesn't matter. They should all have their own health. Their attack power might be super low if they're just like a villager. If they're an enemy, they'll have a higher attack power than a normal player would be. Defense. There's a lot more attributes that we definitely could use here, right? Like I said, if you're familiar with anything like involving role playing, we could have agility, right? What's another one? Agility, luck. I think it might be one of them.
Strength,
Strength,
wisdom,
and yeah, strength,
intelligence,
intelligence. There we go. I was thinking about the magic one. I couldn't think of it.
leadership,
Intelligence. Now we're getting to those subcategories. Yes.
loyalty,
Charisma.
respect,
Yeah. So
honor,
there's a lot of stuff that
personal
goes into
integrity.
it. Personal courage. But yeah, so we can go into all these traits, right? But we're gonna keep it very simple, just straight health, attack power, and defense. And then every single character class should be able to have a get method that's going to return to me their name. I want to be able to grab their health. Grab their attack power. And get their defense. And I accidentally opened up a Python shell. Let me close that up. All right. So we have the basic get methods, and there's a couple other methods that are supposed to go in here. It's going to be attack, take damage, and is alive. Now, I'm not going to completely create these because it might be a little difficult to try to visualize how these work. I'm going to create the method itself, but I'm not going to put any functionality in there until I really need to do these. And you'll understand what I mean. Like it's hard to try to picture how I should be able to take in a target in a dice and then handle the attack. So for now, I'll create these methods knowing that I have to do something with them, but I won't actually give them any type of functionality until I get to them. But one of the methods will be get, define will be attack, right? So attack should be able to take in a target. And ideally, this should be an object, right? My target, my enemy, should be an object instance of an enemy class, right? So the target should be an object. There's no reason why I should be passing in a string here of a enemy name, right? I need to be able to take an object, working with objects here. And then the dice should be a dice object too. So we'll say dice. And we'll pass in object here to let it know that this should be an object. And then all I'm going to do is put pass for now, so I don't get an error. Take damage. Reduces the health based on the incoming damage. This is pretty straightforward. When I read this, it gives me setter vibes, right? It gives me like the vibes that, if I'm going to update my health, so very similar to how the getters and setters work. You just have a method to update a data attribute. So this should be a setter, right? So take damage is essentially a setter method. Take damage. It takes in a damage value, which will probably be an integer. And what this should do is reduce the health based on the incoming attack. So I should be able to grab the health data member and reduce it by whatever damage is coming in. So this should be self._health minus equals damage. Right? Something very similar to this. Just a straight setter. All right. And then the is alive checks if the character is alive. So this should probably be a Boolean, returns true or false. Right? So whenever someone calls the is alive method, it should say true or false. Obviously, true being that they are alive. So this should be is alive. return, we'll say if self.health is greater than 0, return true. If not, return false. Right? I don't need to add the else statement here because it's pretty self-explanatory that if this if check doesn't pass, then it'll never come into line 45. It will skip straight to line 46. So this is the same as just adding the else statement as well. All right, so here, if self.health is greater than 0, then I'm going to return true, letting my game know that this character is alive. If not, I'm going to return false. So this is my base character class. Every character, whether they are a hero, a magician, a rogue, whether it's a goblin, an orc, right? Some, I don't know, a griffin or whatever, a dragon, they should be able to have some kind of name, health, attack power, and defense, and then the ability to take damage and to tell me if it's alive or not. Now, because I create my base class, the reason I'm going to use inheritance is because there might be classes that I want to create later on that should have similar stats as what a character should have, but there might be some very small differences, right? And it would be very redundant to have to manually type out every new class that I want to create, right? Think of what's a good way of explaining this? How can I explain this? I can't even think of a good character. What's a good class that I can use to explain this? Think about magicians, right? Magicians and an archer. And this, let's say if archers have no capabilities of magic, they probably don't have the ability to have mana, right? For those of you understandable with game concepts, they might have every other attribute here, but maybe a magician will have an extra attribute where it's like self dot mana is equal to like 100, right? But not every character has the capability of using magic spells. So they won't have that additional one, but everything else here, they should have it. So what we can do is use this character class as a base template to be able to create subcategories of character. Now, how do we do that? Well, down here, after I create my base character, I'm gonna create my player, right? I can say class player, and I'm going to inherit from character. This is very similar to when we created the exception class and created our own customized exception. Very similar to that. We're going to inherit from character, and we're going to say define init. And in the init method, what we do is we pass in super, open and close parentheses, dot init. And then we pass in the attributes. Because the player character should be customizable, we're still going to pass in name, health, attack power, and defense, I believe is what it was. Name, health is equal to health. Attack power is equal to attack power. Defense is equal to defense. Right, and you might think to yourself, well, Roger, what's the point of doing this if I still have to type out these parameters? Well, I still want to be able for my player class to be able to take in these arguments and create this, but maybe this time around, this one will probably have a different data member, like mana is equal to mana. Now, what this did, it created a version of character that still uses everything else that character has, the name, health, attack power, and defense. And I was able to add an additional attribute like mana and not have to go through the route of reestablishing the init method. Also, I don't have to recreate all these other methods that come with character because player inherits from character, it automatically has the ability to use all of these. Right? So I'm able to create a unique class that derives from the parent of character and not have to repeat my code, but still have the ability to do everything that my parent class can do. Now, I don't want mana, so I'm going to remove this. And then we can say goblin. And the goblin will have the init method. And I'm going to show you where it can become helpful as well. This stays the same. Health is equal to health. Attack power is equal to attack power. Defense is equal to defense. But what if, specifically for goblin, every low-level goblin should start with 3 health. And let's get rid of, get rid of these. We'll call it goblin. 3 health. The attack power will set to 1. Actually, let's not make them too weak. Let's give the goblin 10 health, 3 attack power, and 4 defense. Right? I'm able to recreate a character class for goblin, but this one's a little bit more unique. This one has hard-coded the fact that it's going to be called goblin, and the health and attack power and defense are set. I can have something like goblin elite. The health is 15. The attack power is 4. And the defense is 5. And I could have something like goblin chief. Where the health is 25, attack power is, let's say, 6, with a defense of 10. Right? All 3 of these classes are inheriting from character. If I want to create 3 different unique classes, one for goblin, goblin elite, and goblin chief, without using the inheritance, I would have to recreate all this for the same class. Where this way, I can create one base class. All 3 of these can inherit from that base class, so I can use these methods, but then add some customizable default settings to my subclasses. Does everyone understand what I just did? So in the init method is known as a constructor. Right? The proper term for an init method is constructor. If you learn other classes, that it goes by this name too. The constructor does exactly as the name implies. It constructs your object. It uses the values that you're passing in as arguments to construct your object, right? So the init method by default is always ran the moment you instantiate an object. So when you run the class goblin, it's going to run your init method. And in this init method, what you are saying is, okay, hey, how are you constructing goblin? Well, I want you to construct goblin off of the constructor that its parent class has. That is what super init is doing. Super init is saying, I'm going to initialize, think of super as like parents, right? It's another fancy word that they're using for like their parent class. I want you to grab the parents of goblin and initialize the parent's init method, right? So you're essentially saying, hey, don't use goblin's init method, use the parent class that goblin is inheriting from to initialize goblin. Does that make sense? That's why we have these super init method. We're essentially just telling Python, hey, goblin does not have his own init method. I want you to utilize the one that we're inheriting from. That's what super init is doing here. And because it's the one that belongs to its base class, when I hover over it, you can see there, it requires name, health, attack power, and defense because that's how the base class is established, right? If I change the base class, and add another attribute here, it's going to update it there. Now it's saying that, hey, you need to add mana because the parent class takes mana as an argument, right? So super init is referring to the parent that it is inheriting from. You're essentially just kind of starting it up, right? Does anybody have any questions on my classes? I see a bunch of, no's, but later on you're gonna have a bunch of questions. All right. Okay. So that takes care of 90% of my character class. We obviously still have to come back and do some editing to the attack, but we'll take care of this once we actually have a dice object initiated and we have to use it so we can see how this is going to work. But that takes care of that. Now, let's go back to our classes. So we have the character class and the enemy class are pretty much taken care of, right? Because we essentially created the base class where we create 2 different classes for each version of this. Now let's do the dice. I'm going to create a dice class. We have to construct it to initiate the init method. And the init method. So if we're only using a 20-sided die, then we wouldn't need any kind of arguments. Now, for those of you who aren't familiar with Dungeons and Dragons or how the dice work, there are different forms of dice that are used, right? A regular 20-sided die is typically used, from my understanding, for regular checks, right? If you want to check if your attack hit or miss, you're going to roll it, right? If you step over a trap, you can roll a dice to see if the trap activates or if you were able to step over successfully, right? They use 20-sided dice for that. There's also attack dice, right? Dice that have less sides, like an 8-sided die, that is specifically to calculate if you attack. And I was able to get this real quick from ChatGPT. It gave me the little a reference chart that I can use of how it's calculated. But small weapons like daggers and clubs, when they go to attack a player, you usually use a 4-sided die or a 6-sided die, right? So you can get a number between 1 to 4 or 1 to 6, right? That's saying if you're using a dagger or club, you're going to roll the dice. If it lands a 6, then you do 6 damage, right? If you land a 3, then you do 3 damage. For standard weapons, it's an 8-sided die. The one that you see prior to the D, it just represents how many dice you're using. Because sometimes you can use 2 dice, you roll both of them together, and then you combine the result. This is just saying 1 dice of 4 sides or 1 dice of 6 sides, right? For a standard weapon, you just use a regular dice with 8 sides. Whatever number you get from this 8-sided dice will dictate how much damage you do with sword or mace. For heavier weapons like great swords and axes, they use 10-sided or 12-sided dice because these will hit harder, right? So that's kind of how that works. So with this in mind, we should have 1 20-sided dice for regular rolls, right? To see if we land a hit or not, right? That's what that 20-sided dice is gonna do. Now, after we calculate if our attack hits or miss, we then have to calculate if or how much our attack is gonna do in damage, right? Does that make sense? So we have to roll twice. One to see if we hit or miss, and the second one to see how much damage we're gonna do. Right? So with that in mind, we need to be able to create different versions of dice. So by default, what I'm going to do is I'm going to say sides is equal to 20. So the default for my dice will be set to 20 sides, right? But what this will do, it'll give me the option to update what size is, right? In the event I want to create a dice with only 8 sides, I just pass it in as an argument and it overrides this argument, right? But by default, my standard die should be 20 sides, right? Where for other dices, I might want to manipulate how many sides I have, right? Does that make sense so far with you guys? All right. And then we have to have a method to actually roll our dice. So we're going to say roll. And all this is going to do is return a random value between 1 and the number of sides. So we're going to need random in here. So import, we'll say from random, import rand int. And I will say return rand int from 1 to the max side of sides that we have. So this will be from 1 to 20. If my dice is set to 8, it'll be from 1 to 8. Right? So this row should be able to give me a random number that lands whenever I roll my dice. Any questions here? I know I did not specify the different dice in the instructions. This took a little research of my own, which is why I told you guys from the beginning, like there's room for you guys to run with it and do what you feel best that fits the scenario. I told you guys there was no wrong or right answer, right? But here's my dice. That should work for now. So we have our characters, we have our dice. Now let's do the game. I'm going to bring this down here so I can see it better. All right. We're going to define our class game. And we need to create an init method. This init method is going to create a player, an enemy, and I'm going to create 2 dices. One for my general 20-sided die, and one for attacking. Now, could you make this to run some kind of like while loop to ask the user for like input so they can customize their own character or customize their own enemies? Sure. You guys can expand on this more if you guys like. Well, I'm gonna hard code exactly what I want. So I'm gonna actually instantiate these objects. So I'm gonna say self.player1. Or I'll say player. It's equal to, and we need to import the player class. So let me go ahead and import that. From character, import player. I'm going to instantiate a player object. My name is going to be Sir Roger the Knight. My health is going to be 20. My attack power, I think we could do this too. Health is equal to 20. Because if I don't add this, it will look like just numbers. Right? Which doesn't really tell me much. it might get confusing if I try to understand what I have. So I'm gonna say health is equal to 20. Attack power is equal to, let's say, 3. And defense is equal to 5. Right? This is gonna create my player class. I'm gonna create a regular goblin. I'll call this goblin 1. I need to inherit, or not inherit, I need to import my goblin class. And notice that I don't have to add any arguments. Typically, in these games, all low-level goblins, they don't have unique names. They're just called goblins, right? Goblin, they're all goblins. So I don't have to do that, right? They're either a goblin elite, a goblin chief, right? A goblin warlord, goblin shaman. So that's why I gave my goblin a default setting of what they should be. And then you create different classes for different versions of your goblins where they have like some kind of uniqueness to themselves. But because my goblin doesn't take anything, these are hard coded in here for defaults. All I have to do is just call the goblin class and it just instantiates that goblin. Next, I'm going to create my dice. I'm going to say D20 for a dice of 20 is equal to dice. And I need to import it from dice, import dice. And then I'm going to create a D8 because standard weapons like swords and maces require a dice with 8 sides. All right, so I'm going to create one so I can check how much damage we actually do. And as I mentioned, by default, we have it 20 as the default standard for it, but we still have the ability to pass in an argument here. It's optional, and if we decide not to do it, it'll set it to 20. But because this one has to be a little bit more unique, we're going to say size is equal to 8. Right, so this dice is a different version of what my D20 is. So D20 and D8, these are my dices. Do I have any questions on why I created the objects that I created? All right. So we have the player, we have enemy, and we have dices, right? Now we have our methods. We have battle round. We have start, which is kind of like a run method, and declare winner, which displays the results of the game. Let's start simple. Let's do a battle round. Let's do the battle round first, and let's handle how one round should work. And then once we understand how one round should work, we can use the start method to apply multiple rounds. So we're going to define battle round. Now, a battle round should handle a round where player and enemy attack each other, right? So main player attacks and then the enemy attacks. That's first round, right? It's just one person attacks and the other one. That's one round. So that means that 2 people should attack in one round. So we can dictate who's attacking. I'll say attacking is equal to, and we'll set it to the player to start. And defending, we'll say it's going to be the goblin. Because we're the main protagonist. We're going to hit first. Now, if this game got more complex, right? For those of you familiar with these games, if an enemy has a high agility, high speed, they might have the initiative and then might attack you first. So if the game was more complex, I might want to take that into consideration, right? Before my battle round starts, I might want to check what is the initiative or the speed or agility on my players to see who's attacking first. We're not going to get too complex, but that is an option if you guys want to pursue that route. As of right now, I'm just setting it by default. The player that's going to attack first is going to be player, and the defending player is going to be Goblin one. So we'll say while how do we do this?
Called it is alive. That's what I did.
You could, but they might not kill each other in this one round.
Well, I
So
think you'd. Oh, sorry. You'd set check is alive to like true, and then check to see if it's still true every round.
Ooh, did I give them is alive? I did not, right? That's a good point. They don't even have the action.
You did. You made a function is alive.
Oh, I
Very
did.
last one.
Oh, well, the method checks. Yeah. So I will have to check if they're alive, but that's beside the point right now. So yes, I will have to check. You are correct. Before I even move forward, like, are they even alive? So let's say if self.player one dot is alive and self.goblin one dot is alive, then I'm going to go through the battle sequence. I want them to attack in this order, and then once one attack happens, I want them to switch. So I'm gonna start a for loop. Maybe there's a better way of doing this. I'm gonna say for I in range of 2. Just so I can do something twice, which is them attacking. Right. The first time this runs, I'm gonna have the attacker who is player attack the defending person who is goblin. Once it iterates to the 2, I'm going to switch them, and then the next person will attack whoever is defending, and then that'll be it. So we have to check if they're alive, and we have to make sure each one of them attacks at least once. But maybe what happens if my player attacks Goblin and one-shots him in that one attack? Then the Goblin shouldn't be able to attack right afterwards because he's dead. So maybe it'll be better to put this above the if statement, because they shouldn't be attacking if they're dead, right? My player might be super overpowered and one-shot them. So I think it might be better if I start the for loop and then before I attack, I check if they're dead or not. I don't know. I'm not quite sure how this will work. We'll see. I coded a little bit of this, but I didn't get this far. So if self.player is alive and self.goblin is alive, then we can go ahead and check, or we can fight, right? I want my player to attack my goblin, and we have a method for that, right? But we don't have anything here. So I should be able to call self.player1 and use the attack and pass in the defender and the dice, right? So I'm going to say do I want to use this, or do I want to use attacking and defending? I'll say attacking. Yeah, we'll use attacking. Attacking dot attack. Because we need to make sure we can't hard code self.player dot attack, right? Because he's not always attacking. So we're going to use these variables to ensure we know who is attacking in each round. So we'll say attacking dot attack. And obviously the target is going to be whoever's defending. And we're going to pass in our 20-sided die. Right? So once we run this method, this should calculate if we hit them or not. So let's do that. Now that we know how this is working. Whoever's calling this method of attack is going to be self, right? That is self is that is the person calling this method, and obviously the target is going to be the defender. So let's see if we actually hit them. Well, how is this going to work? Well, from what I'm tracking with the die, is we want to roll our 20-sided die, and we're going to compare that to what the defense of the enemy is. Hypothetically speaking, if the enemy has a defense of 10 and we roll a 9, then we miss. But if their defense is a 10 and we roll a 15, then we landed a hit and we can actually go ahead and do damage, right? So we need to roll this dice and compare it to the target's defense to see if we hit them or not. Everyone with me on that? So we should say dice.roll. We can say hit. We'll say if dice.roll is greater than target.get defense. Yeah. Target.get defense. We did have that, right? Yeah, get defense. The target should be an object of a character. So they should have the get defense method. This will return to me what their defense is. The dice will tell me a number between 1 and 20. The goblin has a defense of 4. Dang, he's weak as hell. Let's make it 8. For the sake of just making it a little bit more competitive here. He has a defense of 8. So if I roll a 9, then it should hit, right? If the roll is higher than defense, then we're going to return true. Else, return false. All this is doing is checking whether we hit or not, right? The attack. If our dice roll is greater than the target's defense, that means we hit, and it should return true. Else, it'll return false. So, with that in mind, I can say is hit is equal to whatever returns back from this method. Does that make sense? And now, if hit is equal to true, then we can calculate the damage that we did to the enemy, right? If is hit, then the defender needs to take damage. So we're going to say defending dot take damage. Well, how does the take damage work? Well, take damage needs to take in a damage integer, and then we subtract that from the health. So we need to calculate how much damage we did. So before we actually run this method, we need to calculate damage done. So as I mentioned before, how do we calculate how much damage we do? Well, the D20 calculates if we hit or not, right? Calculates if we land a hit or miss. And then the other dice calculates damage done to target. So the way this works is that for now, let's just say that everyone has a standard weapon, right? Standard weapons which have an 8-sided die. We're gonna roll this, and the way that, from my understanding, is you roll the dice, and then whatever you get on that dice, you add whatever your attacking attribute is to that roll, and that is the total damage that you do, right? So if our character has an attack power of 3 and I roll an 8, it should be 8 plus 3, which means 11 damage is being done to the enemy. Does that make sense? So damage done is going to equal to whatever returns back from the D8 dot roll plus attacking dot get attack power. This will return to me whatever the attack power is of who's attacking, plus what came back from the row. This combined is going to equal how much damage is done to the enemy, and then I can pass that in to my defender. Right? And we can say something like, print a string here to see what is happening. We'll say attacking dot get name landed a hit for damage done on defending dot get name. Right, so this should say Sir Roger the Knight landed a hit for 8 damage on Goblin. Right, so it should tell me when I attacked them and how much damage I did. And then let's also print out the health of the defender. Defending dot hit name. Health is at defending dot get health. And this is just strictly just for me to understand how much damage was done. Also, after I land a hit, let me just also say that I landed a hit. Attacking dot get name landed. Nah, actually I don't need that. Never mind. It'll be a little redundant. Now this is what we do if we hit. If we don't hit, we're going to print out attacking dot get name missed his attack. That should be it, I believe. Take damage, that we update the damage, yes, correct. Now this is everything that happens for one iteration. Once we are done with all this, we need to switch who's attacking and who's defending. So I'm gonna say attacking, comma, defending is equal to defending, comma, attacking. For those of you who are not familiar with what I just did, all I'm doing is switching variables, right? I'm able to switch the variables in one line. If I don't do it this way, another way of doing it would be temp variable is equal to attacking. And then I would say attacking is equal to defending. And then defending is equal to temp var, right? The reason why I would have to make a temporary variable is because when I reassign whoever's attacking, I lose the person that was assigned here. So it would make it difficult to reassign it to defending, right? So I can either change who is attacking and who is defending in this manner right here, or I would have to create a temporary variable to hold one of their values, switch one of them, and then use the temporary value to switch the other person. Yes, Daniel.
Roger, could you use this method in a bubble sort then versus using a temp variable?
Yes, this is exactly how bubble sort works. Yes. Yeah, so take this as like variable A, variable B, and then this is variable B, variable A. All it's doing is just switching the positions, right? But that should switch them. And then we'll go to our next iteration. We will check if they're still alive. and then go through this process again. Now on the other end of the spectrum, right? Or the other end of the shoe, I guess. The other shoe. Now that's if they're alive. If not, to be fair, I don't know if I want this to continue if one of them died. Right? I guess we should check again. Hmm.
Would you not want to do an L if one of them's dead, then you declare the opposite one the victor, and then another L if where the other one's dead, and you declare that one the victor?
I do. We're supposed to have a method for that.
Yeah, you call the method.
Yeah.
That's kind of what I did.
Yeah, let's see how it works so far, and then we'll go from there. But yes, you're correct. I just haven't completed this, so I wanna make sure that I'm doing this right because I've written a lot of code and done no run of any of this. What is this?
Yeah, you're a lot braver
Lesson-
than I am. I do print statements like every other line, probably.
CD battle game. Okay, let's run battle game. Oh, I need to create this class of game. My game is equal to game, and then call the my game dot. Let's do a start method so this can work because we don't have a start method, right? Our start method should be our run method, right? Define start, and then we will say something like how do we do this?
I did a while loop in the start method, and the while loop would check if both of the enemy and the player are alive.
Yeah, that's probably a good way of doing it. We'll say while self dot player one dot is alive and self dot goblin one dot is alive, and I'm getting some weird stuff here.
You need to put self in the start.
There we go. Thank you.
Yep.
I'll say battle round. What are you talking about, Willis? Self dot battle round. Ugh, rookie mistake. Okay, let's try it out. Start. Self dot player one. Oh, player. Why am I calling it player one? There we go. Okay, let me clear this up. And I already saw an issue when I saw the print statement. Okay, here we go. All right. Sir Roger the Knight landed a hit for 6 damage on Goblin. Goblin's health is at 4. And then it goes to the Goblin. He landed a hit for 9 damage on Sir Roger the Knight. Sir Roger the Knight's health is at 11. I then land a hit on the Goblin. Goblin's health is at -6. And then it ends. Okay. Hey, let's go. So it's working. It's working to a certain extent, right? Now we need to figure out the declare winner. So let's go ahead and put it right here. Define declare winner. And then we can say something like this. If self dot player one dot if not self dot player dot is alive and or not self return false. Return true. Something like that. So after each round, I want to return a variable false or true. If they're not alive, I'm going to return false. If they are alive, they should return true. Right? Now, with that in mind, we'll say something like running is equal to self.battleground if running, where I say if not running, right? It returns false to me. I should declare the winner.
Self-declare winner.
Yeah.
No.
Self.declare winner. You're all right. But there's nothing in here right now, so I'm getting an error. Yeah. So they should return true or false. If it returns false, then I need to declare the winner, which will give me a message. Right. This should say something like who won or who didn't.
Yeah, just check who's dead, and the opposite person wins, right?
Yeah. If self.player.is alive, I guess not. If not self.player is alive, then we will print the victor is self.goblin1. Else, the victor is self.player. This should be get name actually. Right? Something like that. And then we can say break. Or I guess return. Let's try it out. There we go. Oh no, I got whooped. Okay, so Sir Roger the Knight misses attack. Goblin landed a hit for 8 damage on Sir Roger the Knight. My health's at 12. I missed attack again. Dude, I'm struggling, bro. He lands another hit on me, 11 damage. Jesus Christ. My health is at 1. I'm the brink of death. I land 1 hit, but a little too late. Health is at 7. I got murked by a low-level goblin. He lands another hit for 7 damage. I get to -6 health. And the victor is goblin. If we run it again,
You one-shot him.
I one-shot him. All right. There you go. Okay. Interesting. So, yeah, that concludes the Dungeons and Dragons battle game. Do I have any questions on anything that I did or how I reached this outcome? None at all. I was hearing a bunch of feedback from all of you guys. I'm assuming everyone was able to complete this assignment to a certain extent.
Yeah, I only added health potions and critical hits, though I didn't do the multiple enemies thing.
Okay. Yeah, I mean, you could definitely do something like that, right? For each battle round, if it's the player's turn, maybe ask for input. Like, do you want to attack? Do you want to block? Do you want to take a health potion? You can I'll actually, add a lot more to this. You can take into account a critical hit. Do you guys know like a critical hit would be like if you land a natural 20, right? So if you roll your 20-sided dice and you get a 20 off the rip, that could be a critical hit, right? So you can do certain stuff like that. You can obviously add a lot more to this, but this should be the bare basics of how it should your program should have worked. But awesome. No questions at all about any of these classes or objects or nothing like that. Why I did the stuff that I did. All right. Okay. Well, time is 6:32. We finished just on time for our first break. I will see you guys in 10 minutes. Welcome back from your break. We are going to continue on with our lessons. Today we're going to start lesson 10, reading and writing files with Python. So files, essentially just a place to store your data. There's going to be multiple files that you're going to encounter, right? You have basic files like text files that are human readable. These are your Python files, your JavaScript, regular TXT files, document files, CSS files, right? And then you have those binary files, usually not human readable. Think of JPEG, right? JPEG, PNG files, images. If you try to actually read the content of it, you would see that it's a bunch of weird code that you wouldn't understand. Sorry, choking on my water. I did a group project when I was in Platoon where we created a game for my project. We created a game using Godot, the game engine. And part of working in a group is that we required the some form of version control. Right, the version control that we were using was GitHub, and GitHub did not work very friendly with the Godot game engine. When I was working in this group with my friends, we we had to upload all our code, our files onto GitHub so we can use each other's work and work on different parts of the games. I didn't realize how different a text file is compared to a picture file until I had to work with it on GitHub. So what was happening was I was in charge of creating the main protagonist, right, the hero of our game. So I was in charge of creating the main character for our game, and it was an RPG roguelike game. I wish I could. It should be somewhere. I could probably pull it up later on so you guys can see how shitty it is. But I can't. I was creating the main character, and I had another buddy of mine who was taking care of the enemy, and we had two other people in my group who were taking care of the maps, right? The main map, and then you had like mini maps between all these little maps, whatever. Well, throughout the map creation, the other team members in my team were using the main character, right, the hero, to test out their maps, right? Because they obviously had walls and obstacles, objects in the environment that the players should not have been able to walk through, or they should be able to collide with or interact with. So they needed something to test out to make sure that the player was actually not being able to walk over it. If they walk behind the tree, the character should disappear behind the tree, and so on and so forth. Well, the way that it'll work is they would quite literally drag the character from the directory, right? And then you just drag it into the middle of the map, and it would show the character, right? Essentially, they grab the picture file of my main character, and they would add it in there. What was happening when they uploaded this to GitHub, GitHub was tracking that the main character, there was a version of it inside of the map, right? And what happened was I would go and I would update the character. The character was I had this character in development the entire time we were doing this project. He took a long time to get right. But I was constantly making updates to this character. And every single time I made an update, whether it was a small change to the character, it was a different version of what my other team members had on their map, right? So when they would go to update their map, they would open up the next day after I already made the changes to GitHub. They would, pull the new changes. They would open up their map, and their map wouldn't open. It would be corrupted, and we didn't know why. Well, it was because I was changing the hero. Therefore, the hero on their map wasn't matching. So what we had to do is we had to open up this binary file of our map, right? And figure out where in this file is the code for my hero. And all you saw was letters and numbers in different combinations. There was nothing readable in any shape, way, or form, right? There was no actual word. You could not find a single word being made in this file. It was just a bunch of code. So I had to track down, right? I opened up my human file. I saw what the binary code for this file was, and then I had to look for it through this map file, through like hundreds and hundreds of lines of random numbers and letters until I found the combination that's supposed to represent the hero, and then I have to delete it. And then the map would open. And it was a pain in the ass, straight up, the entire time. It happened like 5 different times. The first 2 times it happened, they redid the map because we didn't know how to fix it. It wasn't until the 3rd time it happened, like, yo, what is going on? And we had to go back, open up these files, and actually look through them. And that was kind of like the harsh reality of me realizing, yo, text files are not the same as picture files. Nice little story. But yeah, these are your 2 main types of files, right? You have your text files and you have your binary files. The files that we're going to be working with right now are just going to be nothing but straight text files. And how we can use Python to manipulate these text files. This should seem familiar to some of you guys who've dabbled in Python. Does this look familiar to any of y'all?
Yes.
I figured as much. Right. So there's going to be 2 ways that we can work these files. We'll talk about one way and we'll talk about another one. I prefer one over the other, but this will be the first way. You're going to start by opening the file with the correct path name and the parameter R to read and W to write or A to append. These are flags essentially. But essentially, the way that you open up a file is to use the open keyword. The open keyword, this is built into Python, right? This is how Python works to files. The open keyword is essentially a function or a method, right? Inside of this method, you're going to pass in the file that you're trying to open as the first argument, with the type of file that it is. So name of file.txt, right? If this was in some other directory in your documents, then you would have to put the file path in there. And then the second argument you would pass in here is how you want to open this file. Do you want to open it and just be able to read it with the R? Or do you want to write into it? Or do you want to append to it, right? These 3 keywords will do something different when you open it, right? So what this does right here, it opens up the file in read mode, and it saves the contents into this variable called infile. Right? We call it infile because we're taking in this file, right? We're taking in the contents of this file, so therefore the nickname is infile, right? The command read line quite literally reads the first line of your document, right? So we call the file that has the entire document, and we use the dot read line method, and this will grab the first line from this document and save it into this variable called line. The next code here you see is a strip method. Why do you think we use a strip method?
We hate white space.
White space, yeah. In your text documents, right, when you go to a next line, you don't really think about it, but there is space, right? All that space to the right and to the left of it, that is a space that is naturally going to be added there when you go to the next line, right? That white space that you have to take into account. So whenever you grab one specific line, it's going to have some space at the end, or it might have some space in the front. So you want to remove that white space. So after we grab the line, we strip it with any spacing that we might have, which now gives us a stripped version of this sentence, and then we print it out, right? And now, finally, we close the document, right? So this method that I just showed you right now, it keeps the document open, right? And you can work on it, but then you have to manually close it, right? This is one way of doing things. The other way does not require you to manually close it. This way, we manually opened it and we manually had to close it, right? This is in case you have to do multiple things while this document is open, right? If you don't have to do multiple things and keep it open for a long time, then this is the much better way, right? The much more efficient version of how to read a file. And the way that you do that is with the keyword of with. With open, once again, the name of the file path, how you want to open it, and then you essentially give it like a nickname that you're going to call it or reference it, very similar to how we assign it to this variable called infile. Here we're saying when you open it, I want to reference the document as infile, right? So with open docs.txt, I want to read and call it as infile. And now with this alias set, we can say for line in infile, print line.strip. So they quite literally loop through every single line in this file. As they grab each line, they remove all the white space and they print out each item from the text file. So here on the right side is a little snippet of the text file they have, right? It's just 5 different lines of dogs. And after they open it up as infile, they read through it, they print it out and display it here. Now, what happens if we don't use the strip method? Let me show you.
There'll be extra lines in there, right? Blank lines?
No. Not exactly. Dogs.txt. It was Husky, I think. Husky, Chihuahua, Golden Retriever, Dalmatian. I don't know its actual name. We'll just say Wiener Dog. Dachshund. I don't know how you say it. This is lesson 11, by the way, in your curriculum. We skipped the lesson for a reason. We'll get to that later. But so here's my text file, right? In my read write file, I'm going to say with open. I'm going to open dogs.txt. I'm going to read it, and I'm going to reference it as infile. I do put a colon, right? I do. Say for line and infile, print line.strip. We'll do it with strip first. And we get exactly what the code showed us, but when we don't add the strip method, what's going to happen is it's going to put them all together. Oh, my bad. I'm dumb. You see the extra space in here. I was thinking something else. But yeah, so now you see how with the extra spacing, all this natural space here, right? When all this right here, that's what's being displayed here. All this empty space. We want to remove this empty space. And to do that, we use the strip method. Let me get my dog out of the room. He's panting out of anxiety. Yeah. All right. What if I try to read a file that's not there?
It'll throw an error and end the program.
I believe so. Dogs 1. I think the functionality is different actually. No, you're right. Yeah, it shows an error. No such file or directory. So if you so here's the difference. If you try to read a file that does not exist, it'll throw an error. Where it doesn't throw an error is if you try to write into a file that does not exist. What do you think that's gonna do?
Create the file with the name that you inputted.
Yes, it's going to create the file with the name that you input it. That's where I was getting mixed up a little bit. I don't do this often, but yes, right. If I run this again, there it is, dogs1.txt. So if you try to read into it, yes, we get that issue. But if we try to write into a file that does not exist, it'll create it for us. So it gave us what error? File not found. And we talked about errors already. So this is a built-in error with Python. And as you learned from this previous class, we're able to handle the events that we do get an error so it doesn't stop our program. So yes, we are able to do something like a try and except block to catch that file not found error. Right. I don't think I need to show this. I think we kind of already learned this yesterday. But try and except block will catch that error for you. So we saw how to read, right? But to write, let's go ahead and write into a cats.txt. Obviously, the file doesn't exist. So it's going to create it when I use to write. Now, how do we do that? Let's create a, let me see the list of cats. Siamese, Manx. Jesus Christ, these are actual breeds? Let me put this aside. I'm not a cats person. I've never owned any cats, so I know no breed. I didn't know cats have breeds, if I'm being honest with you. All right, Siamese, Manx, Abyssinian. I'm gonna Google that in a bit. That's actually pretty cool. Cool name. And Savannah. All right. So to write into a file, we typically want to change the name of what this file is going to be, right? When we're trying to read a file that's already created, right? We're trying to take in information. We call it in file. But when we're trying to write into a file, we typically try to reference it as out file. As the name suggests, we're going to send information out to a file. And we're going to go ahead and loop through this cat list. We'll say for cats in cat list. And as we grab one of these cats, we're simply going to write into this file. And the way that we write is we're going to call the file that we opened up out file. And I'm going to say dot write. Now, it could be as simple as saying cat, but when we do this, we're going to get some weird functionality. We'll try it out first. So it created my cats.txt. When I go to it, you'll notice that it did write into the file, but they're all together, right? Whereas when we read a file, it already came with all this white space that we had stripped. When we added to it, we didn't add any white space. So we need to take into account that this is a text file, and we need to create that extra white space to move it down to the next line. So to do that, we can just quite simply add the escape character of /n. And it's going to, if you guys are familiar with the /n character, this stands for new line. So this is going to say, hey, I'm going to grab a cat, and then after that, I'm adding a new line. And when we run this, it'll update the cats.txt and give it to us how it should be, for a cat on each individual line. Now, something to keep in mind, that the write command, the W command, will overwrite everything in a file, right, called cats.txt. So if you try to write using the W command in a file, you're going to overwrite everything. You're essentially going to delete it all, and then you're only going to have whatever you wrote in there, right? So if you want to add to a file, we don't have an example here. You want to use the append, right? You want to use the append method. I think we covered it earlier here. The A, yeah, A to append. I don't think we have a code number for it. Maybe we have to go ahead and try it out. Let's see.
Yeah, that'll just add the cats to the end, right?
Yep.
Repeat them again.
Correct. There you go. And we keep running this. And then I can just do W, run it again. And it will write it. So just important to know how it's working before you start manipulating files and accidentally delete all the contact information for whatever small startup you're working at. Don't do that.
Can you show us the rewrite code again? For some reason, mine, when I changed it to A, it didn't append anything.
So all it is just the R, the W, or the A for the second argument in the open method.
All right, thanks.
Yeah, no problem. Okay. Everything in a file is a string, right? So the items we added were strings here. Now let's say let's create a nums.txt, and I want to write into it, right? I'm not working on the cats anymore, but I'm going to write into a new file called nums.txt, and I'm going to write a bunch of numbers, right? So I'm going to say for I in range of 5. You would think I could do outFile.write, pass in I plus \n, and this will work. But what will happen is I will get an issue here, right? Well, for one, I'm trying to add a string. Like, let's remove that new line. When I try to write in there, I get this issue where write argument must be string, not integer, right? And for one, that's because all these files have strings as text, right? So even if I wanted to write the numbers in here, the number of I needs to be typecasted into a string for me to write it into my file. What the heck? Oh, that's cats.txt, my bad. I was like, what happened? Why are there cats when there's supposed to be numbers? Right? So something to consider is that you must convert all integers and floats to strings before writing them to a file. Right? And then make sure to add a new line character to the end of it, so each number is on a separate line, right? And then let's do from range of 1 to 11 to get the 1 and 10. Here we go. JSON, we're gonna be working with JSON today. JSON, as you guys already learned, stands for JavaScript Object Notation. This format allows you to exchange data between different computer languages. So we're going to be using this today to write into some files, right? So in Python, to use JSON, you require the JSON module, right? JSON is not just something that's just automatically used. You have to import the library for you to be able to convert Python to JSON and so on and so forth, right? So in your read-write file that you might have, your little demo, you're going to import JSON. This is going to give you access to a couple of methods, which is going to be the JSON dumps and the JSON loads. Let's add the cat list again. Siamese, Manx, Abyssinian, Savannah, and Ragdoll. I didn't know that was a cat. We are going to write into a JSON file, right? So this was a TXT file. We're going to write into a JSON file. Why are we learning how to write into a JSON file? Why do you think this is going to be important?
Because if you want to update a list and have a running list, you can use JSON to do that. And like pull from it.
Sure, yeah. The answer that I was really trying to get at was whenever you're working with your front end and your back end, the data that you get from your front end to your back end is going to be in a different format. When you send your Python code or your Python data structures to your front end, it has to be in JSON format. All right, so it's important that we understand of how we're actually going to communicate between our front end and back end, right? Our front end needs to be able to understand the data that's coming from our code, right? Our back end is going to be written in Python, right? We're going to be using the Django framework, which is written in all Python. And we're going to be working with React, which is all JavaScript, right? So when we send information from our backend to our front end, we need a way to be able to convert it into JSON so our front end can read it, right? So it's very important that we understand how to use JSON, right? So here is my Python list. I'm going to say with open, and I'm going to write into a cat JSON file, not TXT, JSON. I'm going to write into this out file, we're writing out into a file. Now, the way that this is going to work, we have to call the JSON module. So we're going to say JSON dot dump. I know, it's funny. The dot dump method. And in here, it's going to take two arguments. The argument it's going to take is what we're trying to dump, right? What data structure. In this case, it's going to be cat list. And where do we want to dump it into? Out file, which is a JSON file. And let's run it before anything else. So on the left side, I now have a cast.json, right? These are two different files. One's a TXT and one's a JSON. Notice the JSON file, my icon is the curly braces. That represents my JSON. And when I open it up, it's not too beautiful, right? You can't really tell a difference of what this is. Obviously, because it's not as in-depth as this, right? But if we had enough information, it should look something fairly similar to this. And this will make a little bit more sense with the following assignments that we're going to be working on. But the only thing you need to understand is this is a JSON file, and this is JSON, right? No, I can't write print, right? Because this is Python. This is not just a list. This is JSON, right? This is not a Python list. So although they look similar, you need to understand that this file understands that this is JSON. Make sense? All right. Now, we have the JSON file created, and it has this information. If you want to read the information that's coming from a JSON, you're going to use the opposite of dump, which is going to be load, right? We're going to say with open. I'm going to read the cats.json file using the R command for read, right? We wrote into one. Now we're going to read from it. And this time it's going to be as in file. And we are going to create a variable here to save the information we're grabbing back. We can call it data if you want. You can call it restored list. Right? Realistically, if this was coming from our front end, it would be something like response, right? I think you guys remember that phrase or data in some kind of way. Essentially, it would be data. So I'll just call it data. Data is equal to the JSON.load, and it's going to be the in file. I'm going to load in this JSON file, and this JSON module is going to convert it to Python. And then I'm going to print out data. Now, you're not going to see any actual difference because, as you know, the list and arrays in JavaScript, they look similar. Just know that this is now Python, right? We loaded in the JSON information into Python readable data. Sorry, had a
Roger, we can't hear you. Or I can't hear you.
Oh, thank you. Sorry about that, Daniel. All right, showtime. Readwrite.py. Our first example. Student assignments. Readwrite.py. This is fairly simple. It's two quick examples. The first practice problem is you're going to write code that opens a file named mary.txt. You're going to write to that file, right? So you don't have to create it. When you go ahead and open a file and try to write to it, as we already established, it'll create it for you. So you're going to write into a mary.txt file, and you're going to write to that file the first 4 lines of the nursery rhyme, Mary Had a Little Lamb, with each line being written on a different line of the file. Then you're going to write code that opens that file and reads it, printing out each line as it goes. And then use the strip method to print off the new line characters. So if you're like me, who didn't have a father, you want to look up the Mary Had a Little Lamb nursery rhyme, because I don't know it off the top of my head. But you can literally just kind of Google it, and I don't know if it's correct. Just hard code it, right? I would say create a list where each line is 1 string, right? So you should have 4 different strings for each line on of the rhyme, and then iterate to that list to write into the text file, and then grab the information back and print it out. That's going to be the first one. The second one is going to be to create a dictionary that maps the numbers 1 through 13 to the names of such and such, right? There's 13 names here. Then write the code that writes the dictionary to a JSON file and reads it as well. So 2 little practice assignments. Time is 7:19. We're going to go into 7:30. At 7:30, I want you to go on a 10-minute break, and then we will reconvene at 7:40 to go over the assignments and move on to the next example. I will see you guys in a bit.
Okay, first of the 2 assignments, read write. Writes a file. Actually, let me delete it. Oh no, did I just I deleted the wrong one? No, I didn't. Okay. I thought I deleted my script, not the file itself.
Yeah.
Open a file, write a file, mary.txt, and writes to that file the first 4 lines of the song. They need to be written on different lines of the file, and then write code that opens the file and reads it, printing the characters to the screen using strip to strip off new line characters. So if I run this, okay, it creates a file called mary.txt. All the verses are on separate lines, and then it opens it and reads it and prints it to the screen here.
Awesome. Okay, now let's see the mapping of the dictionary.
Okay, so like you did previously, import JSON. I created a range 1 through 13. I took all of the names, put them in a list, created a blank dictionary, used a for loop to populate that dictionary with the number name key value pairs. Then I created, let's delete that. Created the JSON file.
Nick, I'm gonna stop you real quick. Just I think it was funny. Is there any reason why you created a variable to hold the range instead of doing for I in range?
Yeah, I
1
was
through 14?
doing fancy things and trying to think too way much about it, and then once I had it, I was like, no, okay, I'll just leave it like that.
Okay, all right, continue.
Oh, and I think at one point, I think I had the range wrong, and it was actually giving me a dictionary that had 2 entries of Jody for some reason. It was putting Jody at key 0 and key 13.
Okay.
So
okay.
that was just a remnant of me going back and forth trying to figure out the simplest way to do that. But yeah, that'd be the easy way to do it instead of making a variable.
Sure. All right.
Open or write the names map to JSON file, and I use the JSON dump function to put the dictionary in the out file. If I run it, it creates that, which you can see it here. And then to read the data back in, you use open with a read as in file, and then I set a variable called data equals to json.load from the in file and printed the data, which comes in here.
Sweet. Awesome. All right. Yeah. Good stuff. Okay. That should be it for the assignment. The next one is another fairly simple one. It's going to be filesum.py. No true explanation is needed from this one, honestly. It's really writing a function named filesum, right? So you're going to create a function that's going to take as a parameter the name of a text file. So in short, it should be like a string, right? That contains a list of numbers 1 to a line like this, right? So you should have some kind of text file created that has these numbers. So you essentially do like filesum.txt. You're going to copy and paste these numbers in there into that text file. Well, the function should be able to take the name of that text file, go through these numbers, and then sum the values up, right? And then write that sum, just that number of the sum, to a text file called sum.txt, right? So, I guess, I'll just read me. Create a file with numbers, create a function to read through the text file of numbers, add the numbers up, write the sum into a different text file. Is what you should be doing for this assignment. All right, pretty straightforward. I don't think this one should take you more than 5 minutes. I think this last one was pretty easy as well. So we'll take 5 minutes on this one, and then we'll come back. We'll get an example for that, and then we'll move on to the one after this, which is going to be a little bit more difficult than these last 3. Let's give it a try. We'll be back at 7:50. My file sum. I'm going to split this bad boy up. All right, we're going to write a file num text. I can either write it manually or I can just go ahead and copy and paste because it doesn't specify about writing into the file and adding these integers. It's just calling the file itself. So new file, we'll say what's called file sum.txt. Right, here's my numbers. Cool. All right. So write a function named file sum. So define file sum that takes as a parameter the name of a text file that contains a list of numbers. So we'll say text file. This function should sum the values in the text file and write the sum, just that number, to a text file named sum.txt. So within this function, when I run this function, I should be able to use this and open up my file. So I'm gonna say with open, and I'm gonna do some string interpolation here. I'm gonna say text file .txt. Or I mean, I could just pass in the whole string of file sum.txt. However you want to do this, it could just be the text file itself, right? And then when you go to call this function, you say file sum, and then here you put in the whole name, file sum.txt. Or you can just put in file sum and then add the string interpolation. However you want to do it, I guess there's no real right or wrong answer. It doesn't really specify exactly how. The point is you should be able to take in the argument of the file name and pass it in here. And we want to read from this file, and it's going to be as in file because we're grabbing this information in here. I want to have a variable called sum where I'm going to add the items in here. And now I'm going to loop through the text from the in file. So I'm going to say for num in file. I'm going to say sum plus equals the conversion of num stripped, right? Because it's a text of a number. For one, it's going to have white space, so I need to strip it. And after I strip it, I need to convert it into an integer, and then I can add it in the sum.
Why not a float?
Or a float. Yeah, you're actually correct. A float. That's a pretty good observation. We have decimals, so probably a float. We might get an error if we try to convert it to integer with a decimal. So thank you for that. At the end of it, return sum. And actually, we don't have to return sum, right? That's not the answer. We have to take the sum and write the sum into a text file named sum.txt. So after sum is done, we should say with open sum.txt write as out file. And then we are going to, and I realize that we have to take care of this part. I'll do it in a bit. But we want to open up the sum.txt. We want to write into it. So I'm going to say out file dot write, and I'm going to convert this to a string of the sum plus the new line for good measure. And now this says the function can't find the file containing the list of numbers, throw a file not found error. So all we have to really do is just say try here, indent this to the side, and say except file not found error, print this file does not exist. And that should be it. Python. We have to go to cd file sum, Python file sum.py. And here's my sum.txt with this number. Nick, did you get this?
Yes.
Awesome. Yeah, this is all you really have to do. For one, you had to create a variable to hold the sum. You had to open up the file, grab each number, convert it into a number, right? Specifically float because we have decimals here, and then add it to the sum, right? And then finally add that sum into a new text file. Does anybody have any questions how to reach this outcome? No questions? We just couldn't finish it in time? Not enough time?
I'm running into a weird error where like it just will not find. Like I tried erasing everything else, it just won't find the file for whatever reason.
Sure. Let's see. It's usually like a file path issue or some syntax.
Let's see. I can't see if it's sharing. Yeah, it is sharing the screen. All right. So like right here, like I erased everything else just to try to make it easier to see, but like file sum or file underscore sum dot txt, file underscore sum dot txt, and then like anytime I try to just it just gives me that where it won't read, where it can't find it.
I think you're in the wrong directory.
Yeah.
But they're saved in the same directory, which is
I think
weird.
he's type in ls.
So
Yeah, when
How
you
do
hit
you-
the play button, I think it runs your program in the
I mean, I
current
can,
in the directory that you're currently in the terminal.
It might be, yeah.
Because that happened to me.
You go into file sum there.
then let's see. I guess just run it now. Python.
Python 3. You don't have the alias set up. The strip
No.
is a method. So the
Oh
line
yeah.
strip, it's okay.
Okay.
But the point is it's working with a file now. It got up to line 7. That means it passed line 5.
Mhm.
So that should take care of it. Also, the file not found error is a built-in function already. You don't have to create a custom made function. It already exists, right? So all you have to do is just treat it as like an actual error. You can just
Oh, okay.
yeah, you don't have to create it. It's already created. But good
Yeah, I
try though.
wasn't sure about that.
No, that's good. I'm glad you still try to get around it. But yeah, now it should work the rest of it. And then make sure you just put this in a function when you get the chance.
Yeah, it's still saying that like
Can only
it's
concatenate
can
string,
contain string, not a
not
float.
floats. So lines for lines. So you're trying to iterate through the line, and at the
Mhm.
same time you're trying to add to that line. So right here, you're saying lines and then lines plus equals lines, right? So you
Mhm.
want to create a variable called sum. Does that make sense? For
Yeah.
example, so go to your file sum.txt. When this is a line, this is a line, this is a
Mhm.
line, right? So every time you iterate through this, you're grabbing one of these lines. Now go back to your file sum.py, right? That's what you're doing here. You're saying for lines in file. So you're grabbing one of the lines, and then you were saying lines plus equals lines. So you were trying to add it to itself, which wasn't going to work, right? Because lines right here, these two lines would have been string still. The only thing that wasn't a string was this because you were typecasting it. That's why you want to create a separate variable that you can use to increment, just like I did. All right, and make sure you can do like sum equals 0.
Just
You
to
want to
initiate it.
yeah, you want to initiate the variable. Set it to 0. Yeah, you should be fine now.
There it goes. Yeah.
Yeah,
Which
so
is not the answer you guys got, which is kind of
yeah,
weird.
so Go back to filesum.py. Right. So after you did all this is good. Right. But what you want to add into sum.txt is not lines. You want to add
Yes.
sum. Yes, sir.
I see. Yeah. Not showing nothing.
Go
You got
back
an
to it.
error.
Got an error.
Yes, because this is an integer, right? This is an integer, and you're trying to add it to a text file, so it has to be a string.
So just typecasting in there.
Yes, sir.
There it
There
goes.
you go.
Slowly figuring things out.
That's okay. This next one's gonna take it for a loop. All right. Let's see. The next one's gonna be SAT data. Actually, I really like this one. Let's see. Hold on, give me a second. Oops. All right. Am I sharing my screen? I'm not, right. Okay. All right, SAT data. This one is significantly harder than all the ones that we just did. Right. So this last assignment, we wrote it into a function. This time we're going to implement objects and classes to reading and writing. Realistically, am I recording? Yeah. This is what you're going to need to do in your assessment. You're going to have to use reading and writing files in objects and classes. So this is good practice. You're going to write a class named SAT data that reads SAT.json file and writes the data to a text file in CSV formats. Right. So here in your SAT data directory, if you see on my left side, you have two files. One is a text file. You know that because of my icon. Also because it ends with text. Oh, my bad. One's a TSV file. My bad. Uh, so yeah, I mean it is a text file, but it's a CSV. Does anybody know what CSV stands for?
Comma separated values.
Yes, comma separated values. So this is your text file, or I guess CSV, and here's your JSON file. Install. Give me a second. You might want to install Rainbow CSV. I think I told you guys to install this a while back. I never did, but this is gonna make the CSV look a little bit better. Yes, sir. There we go. So here's your comma separated values, right? It's a lot of data. Look at all this. This is pretty accurate to how much data you might be working with in real life. Right? This is a text file of the SAT College Board of 2010. Right? At the very top, the very first line we have is the headers. Right? The headers is what dictates what each of these columns is. That extension that I just installed, Rainbow CSV, what it does, it provides coloring to help you differentiate the different columns to their corresponding headers. So if you don't have Rainbow CSV, make sure you install it. But here we have a little bit of data, and we'll talk about it before I let you guys go on your own. Here we have DBN, which looks to be like a serial number, right? 01 and 448, 01 and 450, and 458, and 509. It looks to be like a numerical order, right? And then eventually it gets to 02. And then 03. Yeah, it looks like to be it's numerically organized, right? Or alphabetized as well. It's ordered. The next one is the school name. That's the next header. So we see here Henry Street School for International Students, Satellite Academy, American Sign Language, English Dual. There's a bunch of different school names. Afterwards, we have the number of test takers. How many people took tests from this school? 31, 60, 69. And I know that because of the coloring of my headers, right? And I want to point this out. There are some schools that aren't going to have any data, right? You see how there's nothing here. So be aware of that. So after the number of test takers, we also have critical reading mean, which is 391, 394. So we see the mean for all that. We see mathematics mean, and then we see writing mean. So this is all the data from the SAT scores for 2010 for these specific schools, right? Here is the JSON format for it. So the reason why we have the CSV is to show you what it should look like by the end of it. So this CSV is kind of like how your final product should look like. So you're essentially trying to mimic this outcome here. Now, from what? Well, you are going to have to parse through this JSON file right here. And yes, it is a lot of data. Right. I'm not going to break this down of how it's broken down because this is part of this assignment. You're to parse through this data, find where in this SAT.json file is the data that is going to be required for the school. So you need to find where the DBNs are located at, as well as the school names and their corresponding scores, right? After you find it, you need to be able to format it and make it look like this. That's it down and dirty. Let's go ahead and read through it a little bit. Right, so you have to write a class named SAT data that reads the JSON file, this, and writes the data to a text file in CSV format, which is the one I showed you how it should look like. CSV is a very simple format, just commas separating columns and new lines separating rows. Right? You'll see an example of the CSV format below. You already saw it. There is a CSV module for Python, but you will not use it for this project, so don't worry about that. Your class should have the following: an init method that's going to read the file and store it in data members that you prefer. So whatever data member you want to create, you can create it. Just make sure that you can store the data into something. Any data member of the SAT data class must be private. So make sure that you add the double underscore or the underscore before it. Next, you're going to create a method, right? Notice the keyword method, not a function, the method. That means this should belong to the class. The method is going to be named save as CSV. It's going to take as a parameter a list of DBNs, right? The DBNs were these right here. It's going to take a list of DBNs, district bureau numbers, and saves a CSV file that looks like the SAT College Board CSV file that I showed you, but with only the rows that correspond to the DBNs in the list that is being passed in as a parameter. Also, the row of column headers. So you need to make sure you have the headers there. You may assume that all the DBNs in the list passed to your method are present in the JSON file. The rows in the CSV file must be sorted in ascending order by DBN, just like you saw on the CSV file. The name of the output file must be output.csv. So you should be able to take in a list of DBNs, parse through your data, create a new file that you're going to write into called output.csv. And it should look like this. Here is, we create an SAT data object. We then create a list of specific DBNs. And then we call the object and use the save as CSV method. And it should output a CSV file. You may hard code the column headers instead of having to read them from the JSON file if you would like. Some of the school names contain one or more commas. How should you preserve such a name as a single field in CSV format? So you have to keep that in mind. Since commas normally separate fields. The correct way to handle that is to enclose such names in double quotes in your CSV file. If you open up the example of the CSV file in a text editor, you can see that's what it does. But yeah, don't get intimidated by all this data. It's a lot of noise, but I promise you it's a lot easier than you think. You just kind of have to read through it and find the area where the information's at. Let me see if I can show you. Give me a second. Let's go to the curriculum on GitHub. Lesson 11. I'm going to show you how it looks like in GitHub. SAT data. This is how it looks like, right? The CSV file looks different in code, right? It looks like this here in the text editor. But here you can see how it's supposed to look like, right? When you actually open it up. It's essentially an Excel spreadsheet, by the way. The Excel spreadsheet, let me see if I can show you. Let me pause my sharing because I might have something pulled up on my Excel spreadsheet that I don't want you guys to be looking at. Private info. Give me a second. Okay, resume sharing. I got a lot going on here. Where is it at? When you export in Excel, you're able to change the type of file type. You could do CSVs, text format separated by commas. So you are able to quite literally take an Excel spreadsheet, right, and have this output in the CSV format. So that's all this really is, right? It's just an Excel spreadsheet. You got the headers, the rows, right? All these are columns. So don't be intimidated by this. What you might realize is when you try to do this for information that has no data in certain columns, it'll probably give you none here. I don't want none. I want this to be empty. Okay? So make sure you guys are able to figure that out. This is going to be the last time for tonight because it's going to take a little bit. Do I have any questions? Okay. I'll break you guys out into your breakout rooms. And if you need help, I will meet you there.